All right, so in this video, we talk about differential equations, part of your P3 syllabus. And I'd like to explain the concept of differential equations using two examples. The first one, where the equation, the differential equation, is given to you, from which you need to um, remove the dy by dx and get to the original equation as asked in the question. In the other type of questions, you will be given a scenario from which you have to first construct a differential equation and then solve it. Now, in this question, it says when y equals to 0, the value of x is 1, and then you are given this particular equation, which is called a differential equation because it has the component dy by dx in it. And the question says, given all this, express y squared in terms of x. Now, what we essentially have to do is find a solution to this differential equation, meaning find the original equation from which this particular differential equation was derived from. And basically, the idea is to get rid of the dy by dx. And by now, you should be guessing that we have to do some sort of integration because it is integration that gets rid of uh, dy by dx. So, right. So you should be guessing that we need to do some sort of integration because it is integration that gets rid of dy by dx, and that is exactly what we're going to do here. We're going to do some sort of integration. However, we're going to approach this question more methodically. Before jumping into integration, we need to first organize the equation. All right. So the first step to solving. So how do we go about solving this? So this is the solution. The first step to solving differential equations is to separate the variables. All right. Now in this case, the variables are basically the y related terms and the x related terms. What we want is the dy to be on one side and the dx's to be on one side, and all the y related terms, all the y terms with dy, and all the x terms to be with dx. That is the essence of this step, separating the variables. Now, one thing we need to keep in mind, whenever you do separate the variables, make sure the dy is on one side, but it is on the numerator of that side, and the dx is the same on the other side, but on the numerator. We do not want the dy's and the dx's to be part of the denominator, because when it goes to the denominator, integration is not possible. So what I did essentially is kept the dy on the left side, took the dx to the other side by multiplication. We are left with this now. Now, we're still in this step. We are still separating the variables. The next step I want to do is bring all the y's to the left and all the x's to the right. So let's take the entire thing to the left by division because it's a multiplication to the right. There you go. And what about the x? Take it to the right by division. So the next step, so now we're done with separation of the variables. The next step is to put the integration symbol and start the process of integration on both the sides. So this step is integrating both the sides. So this is the most critical part, because separating the variables should be easy. It's just changing the subject. It's just finding a way to put the dy on the numerator and dx on the numerator to the right. But after this is the step where you need to recall all the different ways you learn to integrate, all the different methods of integration. So we have two sides that need integration, the y terms and the x terms. Now, the y terms may require one technique while the x term may require another technique. So you need to be very open to what kind of integration you may have to apply. Recall from the integration chapter that we learned various techniques of integration. For example, integration of reciprocal functions after partial fractions. We learned how to use integration by parts. We learned how to integrate sine squares and cos squares using the cos 2 theta formula. We learned how to integrate using the f prime x by fx formula, right? And there were other formulas as well from the new syllabus. You need to keep all of those in mind because you never know which technique might be required in solving each of these integrals. So let's start the process of integration in this case. Now, obviously, I can see that the right side is easy to integrate. 1 by x has an integration of ln x. Now, let's put some sort of constant of integration. Let's call this c1, ln x c1. This is the constant of integration to the right. Now, before we deal with these constants, the plus c part, let's finish up with the integration on the left. Now, when you look at this question, you need to ask yourself, what technique should I be using? Should I be using substitution? No, no substitution is given to you. Should I be using integration by parts? Not really. We don't have a product here. So we can't use integration by parts. Can we use anything related to trigonometry? No trigonometric function. So ultimately, this isn't any reciprocal function either. This falls under the category of f prime x by fx. How? Well, the denominator is y squared plus 4. And the differentiation of the denominator leads to 2y. But you only have y. Nonetheless, y is some multiple of 2y. So we can do some adjustment for the 2, but nonetheless, we have to realize that there is scope for this formula over here. So let's revisit that formula from integration. That the integration of f prime x by fx is equals to ln of fx. So the first thing we want to do before applying this technique is to express this integral in the form that we like, in the form that we want. And the form is this: the dy, the f prime x on top and the fx on the bottom. But this is the form we want, not the form we have. So we need to somehow adjust so that the line above and the line below are equal. For that, I need to multiply a half. Because when I multiply a half, this 2 and 2 cancel each other out, making sure the value of this integral remains the same. It's just the format that's changing. The format in the form that we want. So now I can use the formula. The half on the outside, because the integral now has an f prime x on top and the fx at the bottom, we can now apply the formula, which is ln of the denominator. And then you can put a constant of integration, c2, and there you go. The integration is complete. However, we need to do something about the plus c. So instead of dealing with two different constants, how about I do this? I combine these two constants one way or the other, that's not really important, and leave myself with an overall constant of integration. Suppose this is c1 minus c2. This is c1 minus c2. But all I have to do now is figure out the value of c. c1 or c2 do not matter to me anymore. The plus c is what I want to figure out. So we're almost done with the integration. All I have to do is figure the plus c out, and that's where the information comes in. Y equals to 0, x equals to 1. So when y equals to 0 and x equals to 1, when you do the math, you should realize that the answer to c is ln 2. Let me rewrite the whole thing so that we have something more organized. After all the integration and all the arrangement, I am left with half ln y squared plus 4 is equals to ln x plus ln 2. Now let's not forget what the question asked. The question asked us to make y squared the subject. We're very close to achieving that. So the idea is to bring all the logarithms together, or to make sure the left and the right each has only one logarithm so I can equate them. How? Get rid of the half by making it the power. Now, logarithm is a very important chapter in order to solve questions from this chapter. So make sure you have a strong grasp of logarithm. And let's combine these two. Now, because ln of this is equals to ln of that, I can say this is equals to that. So root over of y squared plus 4 is equals to twice x. And if I make y squared the subject, getting rid of the root over, I should be getting y squared is 4x squared minus 4. So that's it. That's literally how you solve this question. But some steps are generally the same for all differential questions. Number one, you always start off with the variables separated. Make sure the dy is on top on one side and dx is on the other side, again on the numerator. The next step is to do integration using the appropriate techniques, and then figure out the value of c, and then slowly, using your knowledge of algebra and other chapters, figure out what the question asked you to do. So hopefully that makes sense. So in the next set of questions, we talk about how, given a situation, you need to devise a differential equation and then you need to solve them.